design for recycling and turning circular design into an industry value proposition. Consumers, of course, want circularity. We heard about that earlier on, and brands want it too, but they need credibility. And without something like smart, scalable design, obviously, that's going to allow things to be recycled or facilitate the ability to recycle them, neither one is going to get any further. So next up, we're going to explore how actual design can bridge that gap and turn circular intent into a product reality and into, of course, real value for business, brand, and consumers. So please put your hands together, and it is a pleasure to welcome Jaap Rabou. He's Senior Director, Marketing Polyolefins Europe at LYB. So it's great to see you here. Warm welcome to Jaap. And joining him in this tandem presentation is Erik Edelman from one of their customers. He's Chief Sales Officer, Bischof Klein, SE, and Co. KG. Wow, we've got a lot of short forms there. I'll leave it to Erik to explain those. Warm round of applause, and off you go, guys. The floor is yours.
Thank you, Karen. Okay, Nancy was mentioning that she's German and speaking American English. I'm Dutch. I speak Dutch English, so I apologize up front. So Erik and I, we're going to present today to you a couple of practical examples of how you can drive circularity and low carbon future. So we are both passionate about brand owners, retailers, and anyone in the value chain who set those climate and circularity targets, because we believe that those can go hand in hand. But it starts all with design. The design of a well-designed packaging. Because if we don't have a well-designed packaging, the chances that we end up with a good circular economy and a low-carbon future, gets slimmer and slimmer. So that said, design for recycling strategy starts with collaboration through the value chain. So collaboration was already mentioned in the previous presentation, and that's why we wanted to do this presentation together, the polyolefin producer, LyondellBasell, with the packaging producer, Bischof Klein, and actually they are working together with brand owners to help to achieve their targets. So maybe I need to have a clicker. That would be good. So here we are. But before we go to these two practical examples of how you can drive circularity and low carbon emissions, we want to make sure that we don't lose sight of functionality. Because this industry has been actually innovating for decades with new innovative packagings to the market to drive functionality, but also to improve consumer appeal, to drive and reduce resources used to the packaging, and also to improve productivity, the speed on the lines. So all of that are still requirements we need to take into consideration. But now we need to take additional needs into consideration, which are circularity and climate. So how are we bringing all those requirements together? That requires to rethink the design of the packaging. And actually PPWR, it has been mentioned a couple of times in the meantime, is accelerating the necessity to rethink the design. Because PPWR is focusing on recyclability at scale and incorporating recycled content in the packaging. So with PPWR, we will address that circularity piece. But on top of it, it's not mentioned in PPWR, there is a lot of voluntary commitments by the brand owners on reducing their Scope 3 emissions. And while we are rethinking the design of a packaging, why not focusing also on reducing the greenhouse gas emissions of those packagings? So we combine circularity and low carbon solutions. Obviously, we talked about creating value out of those activities. Unfortunate PPWR, if you have a product on the market which achieves that circularity, you create value through paying less EPR fees. And we will give some examples on that as well. So, how can such a journey towards a circular and low-carbon future look like? I'm going to show you something which is illustrative. Yeah, so don't come back to me, so it's a cautionary statement. So, it starts with reduce, something we've been doing in this industry for decades, for those who are already decades in this industry. Reducing the amount of resources per packaging is obviously the fastest way to reduce greenhouse gas emissions. It reduces cost. So we've been down-gauging the packagings. We've been changing the pack types from rigid packaging to flexible packaging to reduce resources. So all of that has been very good, yeah, but it's not enough. So more needs to be done, because not necessarily those activities have supported us to drive circularity, because we've created packaging which actually was not that easy to recycle. So if we want to have a circular economy, we need to start focusing on, again, changing the type of that packaging, where we make it less complex. So we move from multi-material packagings to mono-material packaging. And while we are doing that, we also change material types. And obviously, I'm speaking here on behalf of LyB, and obviously polyolefin is the material of choice if you want to achieve that. So, if we have done a mono-material solution and we have changed raw materials, yeah, there is another step we can do. Then we start incorporating post-consumer recycled materials. For non-contact sensitive applications, we obviously can involve mechanical recycled content, which we are covering with the Circle and Recover portfolio. If it is contact sensitive applications, we need chemical recycling. And we are going to talk about chemical recycling, obviously, today and tomorrow more. And we can cover that through our Circle and Revive portfolio. And while we are doing that, again, we are driving circularity, but we are also reducing the greenhouse gas emissions of the packaging. But it doesn't stop there. We can even go further. We can start focusing, while we have done that, on further reducing the greenhouse gas emissions of the packaging by changing the fossil fuel feedstock by biocircular feedstock. And that will reduce our Scope 3 emissions, which will support your Scope 3 emissions. And all of that is actually already available today, right? So if we think here and we look at presentations of 5 or 10 or 15 years out, this is what we can do already through collaborating. Actually, we can even go a step further. We can start reducing further the product carbon footprint of our product by offering green energy PPAs. That will address our Scope 2 emissions, which will support, again, your Scope 3 emission reduction target. And once we have done that, we can also work on our Scope 1, our direct emissions at our manufacturing site through energy efficiency programs, by increasing the use of hydrogen, by carbon capture and storage initiatives or use initiatives. Obviously, these initiatives are not available yet, but we are happy to talk with all of you on how we could collaborate to create that famous business case, which Yvonne has been talking about earlier today. So this is a theoretical roadmap of how we can drive circularity and low carbon emission packaging. You don't have to follow all these steps, and obviously it's illustrative, but what it can show you is that there is already a lot available and that there is still a nice future ahead of us. And now I will hand it over to Erik, who will talk about a couple of examples by following this roadmap.
Thanks, Jaap. So when Jaap asked me to join, I was really thrilled, because what you just saw in theory, we actually wanted to substantiate with some real hard evidence out of the European markets that we operate in. At the end of the day, we know in the first step in the past, we've tried multiple times and been successful by reducing the packaging size and the weight by switching from a rigid to a flexible pack. And you can see that here, a substantial reduction in product carbon footprint is the result by over 40%. However, and this is the problem with laminates that we have, for example, here in the automotive space, this is for a windscreen washer, those laminates are typically 3-layer structures, typically a PET level, an OPA level, and a PE level. And those different layers, per se, by default, are not recyclable. So for us then to say, how do we take it to the next step, and this is where the collaboration comes in, how do we ensure that we still have that functionality that you alluded to, but at the same time, we replace the layers that you see here at the middle section, with monomaterial PE layers. So we're still at 3 different layers, but we're of mono PE composite level, which ensures, in this case, a recyclability of 98%. And with this, if we listen to the PPWR expectations for 2030, we can tick the first box, which is the recyclability of the packaging that is required. Now, that's only the first step. This is where we are today. And the next step is using recycled content to be included in that recipe. So that can be PCR mechanically generated, incorporated into the body of the stand-up pouch, or also PCR for that spout, which you use to then basically dose the liquid, in this case the windshield washer. If we do that, and we've done that with mathematical calculations, we can reduce the carbon footprint by another 8%. So yes, the step is smaller than the prior one, but going from -25, another 8% down. And this is essentially what we want to do, and this is why I think it's so motivating to see. We can already today achieve some of tomorrow's requirements of the PPWR by collaborating across borders and across the entire value chain. Next, in the red section, we heard that earlier from Jaap, is then trying to meet your voluntary brand owner commitments in terms of zero emissions. Net zero emissions that you have basically pledged to can be met by further reducing that in scope 3, 2, and 1. Another example that's a little trickier because it's food application, in this case coffee packaging, is that we also have the opportunity here to reduce the layers again. In this case, it's usually an aluminum layer in the middle section, so 3 layers, PET, aluminum, and PE. And we did this here as well. We replaced 2 of those layers with MDO PE, 1 metallized, 1 non-metallized, and we're able, and this is probably the bigger drop versus the prior example, able to decrease the product carbon footprint by 40%. Why? Because the aluminum in the aluminum layer is very energy intensive, so you get a big benefit by reducing that aluminum layer and putting a PE layer inside. The tricky part with these contact-sensitive applications, after ticking the first box of recyclability, in this case up to 96% for the coffee application, is how do you manage in the future now recycled content that by 2030, according to PPWR, for these types of applications should be above 10%. We're not going to be able, as of current state, be able to use mechanically recycled content. So this is why over here we also said we are looking at incorporating chemically recycled content to get over that threshold of 10%. Now, we talked a lot about circularity, so recyclability to a certain degree that is necessary by 2030. So we should achieve at least 95% recyclability or more to be able to comply with PPWR by 2030. We talked about including recycled content to make sure that we have that PCR component ticked off on the PPWR, and we talked about additionally decreasing the product carbon footprint. What we haven't talked about is associated costs. And yes, all of these things that you see require costs. We will have to invest in R&D, we will have to invest in CapEx, we will have to invest in new machines. And with the recycled content, I can tell you quite honestly, we at Bischof Klein initially did struggle a lot because we didn't get consistent PCR quality from mechanically recycled material. First time I went to the plant, you could basically smell it, you could see it in the air. But again, collaboration with suppliers, collaboration with machine manufacturers, the OEMs, what operating windows will you use? What are the best optimized solutions to get to that window and be able to process those recyclates gets you to that next level. But those are not the costs that all of us incur that I want to talk about. The big piece here is the EPRs. EPR in terms of extended producer reliability. And this really targets at one thing and one thing specifically only. Ensuring that the future packaging is fully recyclable. And you can understand that just like with taxes. If you increase taxes and you make them high enough, if you turn it up a notch and turn it up a notch, people will tend to move towards where you want them to move. I mean, EPRs in general are rather simple and very effective. So the concept is you penalize structures, you penalize the use of materials that are less environmentally friendly than others. And by doing so, you push us, the converters, you push the whole value chain to move to more recyclable packaging. Obviously, 2030 is not that far away. Jaap and I were talking about this. Most of us think we need to really get going to get there because you don't want to be the last one through the door in Q4 2029 saying, oh, I got to do something and I run out now. We have to start now, and this is why this is so important, this event here as well. So making sure that we decrease the fees, and I can tell you the fees will be increased by the governments, by the different EU states for sure from now until 2030, but we have it in our own hands. If we collaborate across the whole entire value chain, we can make sure that we have structures in place that reduce the fees. The challenging part, and I know everybody was looking at me, where's the but? The challenging part, it's not a harmonized European fee. So every country in the EU right now has their own way of looking at it, their own way of assessing it, their own way of calculating EPR fees, and their own way of actually then saying, okay, this is what you need to be paying us for a certain level of structure that you use in place. And you can see that on the right-hand side. In Belgium, for example, for this estimated EPR fee, the fee is 5 times as high as in France for a PET aluminum PE case. But if we take that aside, there's one key message here. If you look at left is a less environmentally friendly version. On the right side is the fully recyclable version. The higher the recyclability of the structure, so the higher the degree of recyclability of the structure, the lower the fees. And this is exactly what all of us are trying to utilize to say this is a great way of pushing towards fully recyclable packaging rather sooner than later.
Yeah, thank you, Erik, for providing those 2 examples. Obviously, there are multiple other examples we could showcase with many of the companies actually here today. But I think the key takeaway of this is that going through that journey of achieving circularity and climate targets, we have already a lot to offer. Some things are available today. Other things are available maybe tomorrow or the day after tomorrow. But it starts with collaborating and exchanging what your needs are and how we can support. And I think as a company, we like to think big. So when we think about further down the road, and decarbonizing assets, lowering our product carbon footprint, adding more capacity on chemical recycling, I think that collaboration is really, really important. On this slide, you basically see LyondellBasell. We have a portfolio for all these different steps, whether it is, driving from multi-material to mono-material solutions, whether it's about incorporating post-consumer recycled content, whether it's about biocircular products, all of that is available. We have technology, we have the ability to scale things up. We have an integrated system all the way from recycling to finished quality products. We have people who have experience for decades. They know our technology. We have the ability to test applications in our testing centers. So I think, it's just a matter of getting somewhere started, application by application, to drive those trends as we have just shown you.
Maybe to wrap it up on our last slide, I think we talked a lot about collaboration and how important it is. But besides collaboration, I think for Jaap and myself, there's really two key takeaways here. The one thing, we have to think the whole process from the end. So we have to start with the right packaging design. If you don't have that design, if you don't have that DNA, it's going to be very difficult to achieve recyclability and to incorporate the respective recycled content. The second piece outside the collaboration is a continuous process of improving. With the fees, we said we want to optimize to minimize the fees, but we have to continuously optimize the structures of the packaging and the packaging design per se to minimize the impact on our planet. And if we do it right, or if we do that right, we also make sure that we minimize the impact on our pockets, because the EPR fees will definitely be lower if we do the right thing. So essentially, if we tick those three boxes, start with the right design, collaborate across the value chain, and I'll keep it short, have a Kaizen mindset on this and keep on driving it, I'm positive that we will really be able to have a truly circular and low carbon future. Thank you.
Thank you.
Thanks a lot to both Jaap and Erik. And we do have a couple of questions that have come in here over WOPO, and I'm wondering if there are any hands that are going to shoot up, because we also do have a microphone here on the side of the room. And if I don't see any hands shooting up because one of these questions, oh, there is one right over here, two hands even. Jim Guilfoyle.
Thanks for the presentation. I guess it's always good to see material applications. Just a quick question on, say, the coffee. Performance changes, oxygen barrier, same level you had before with aluminum, life cycle of food, or is there going to be more waste? Or how do you work through that? Because it looks like it was designed the way it was designed for a reason, probably.
Yeah.
And I know maybe we didn't think of monomaterial as a driver, but have we lost anything on the performance side?
Yeah. So from a barrier, as you said, we haven't lost anything because we've been able to replicate that. In terms of shelf life, it is within spec from what they've currently have. But there are examples also in the coffee industry where we haven't been able to replicate. It depends a little bit. Is ground coffee, full bean, pads, the whole game. In this case with Dallmayr, they said, look, this is what we need, and they didn't reduce their spec at all. I have come, and I think this is also our responsibility as a converter, I have challenged some of the brands, and I said, look, is it really the 24 or the 26 months of shelf life that you need? Or is it okay to do 22 and we can still give you that USP? Because right now, there's a lot of them that use it as a USP, because I can tell you when I started with Bischof Klein, we had a lot of solutions in the drawer, as we say. But people were hesitant to actually make that switch and say, well, we don't want to, as you alluded, compromise on certain technical aspects. And if you go into that discussion, I think it's a valid point to say, look, what do we really need? And what is that where we maybe say, okay, that's something that we can still live with? And that goes shelf life, drop tests that I've seen dropped from 12 meters to 10 is enough, because that's the way our warehouse is structured, and we don't go on the roof to store the pallets, but we stay within the building. We've really had a good success with addressing those topics from both sides, right? From putting ourselves into the shoes of the customer, as well as, or the brand owners, as well as saying what can we bring to the game or bring to the table.
Thanks very much for that question. There's another question here from Paul, because you were talking about costs, and of course there's costs at every level. The question here is, how large is the capital investment to move the windshield cleaner from rigid plastic to flexible plastic?
Well, we're not a supplier of rigid plastic, right? So we do flex pack. What I can tell you is what we had prior to this in our production site, and the adjustments that we made in the second to the third step, right? From the PE pouch, the stand-up pouch, to the 3 layers that are all mono PE. That investment was less than 25,000. It's not a huge investment.
Okay.
But from rigid to flex pack, I don't know the rigid side well enough to make that judgment call.
And do you have experience working with customers involved with products for pharmaceutical use that are having difficulty creating eco-design products due to pharma's conservative nature, and what could you recommend that they do?
Definitely we do. All of them are currently looking at the chemically recycled content. Mm-hmm. Yes. And there are actually startups that try to collect pharmaceutical waste, I would say, that is not burned. So some of the stuff that you see at hospitals after the surgery obviously needs to be burned. But others, let's say they're outside wrapping, or when you take out utensils, medical devices to then be employed in a surgery, those are actually already getting collected. But the cycle is not a closed loop. So right now they're all talking about chemically recycled content.
And there's a question here about who has really pushed this approach. It's interesting because you've really done a sort of a taking the initiative and getting out ahead of regulation, and yet you're finding you're tripping up at places like where suddenly lack of standardization comes into play. What can be done about that, and what would be also your advice to others in that role?
I think initially we also do hygiene packaging, so packaging for toilet paper. We've been pushed by 2-3 of the big players in that field quite a lot, at least on PCR, right, including post-consumer recyclate. And then we collected our learnings from that, and we said, look, this is probably the easiest packaging for us, because no lamination, no spout, no nothing, blown film, printed, packed, done, put the toilet paper in. So that for us was the PCR learning of it. The trickier thing is really the layers. What layer can you replace with what other layer and still keep the mechanics, the technical requirements intact? Yeah. But I would say an open discussion like we had this morning with some of you at the table, but also in the lunch break, looking at where can we live with trade-offs and where can we absolutely not live with trade-offs. I think we have to have an open discussion.
Thank you very much to Erik Edelman and Jaap Rabou for that very interesting look into getting ahead of regulation and incorporating circularity into design. Thanks very much, guys.
You're welcome.
Give them a round of applause.